Hello everyone, welcome back. So in this video we are going to learn about another type of flip-flop, which is D flip-flop. Okay, so if you are first time to my channel, please consider subscribing. So D flip-flop is called delay flip-flop. Delay flip-flop, or it is also called transparent flip-flop. Transparent flip-flop. Okay, so it is also called transparent flip-flop. So D flip-flop, so there are two conditions. There are two conditions in SR flip-flop which are to be eliminated, because Qn plus 1 is equal to Qn when S is equal to 0 and R is equal to 0. So when S is equal to 0 and R is equal to 0, Qn plus 1 is equal to Qn. So there is no change condition, and Qn plus 1 is indeterminate condition when S is equal to 1 and R is equal to 1. So this is indeterminate condition. So these two conditions are going to be eliminated. These two conditions are going to be eliminated in D flip-flop. Okay, so D flip-flop is not a new concept. It is again derived from the SR flip-flop by eliminating these two conditions in SR flip-flop, because these two conditions are not useful for us. So that is why eliminating these two conditions we'll get another type of flip-flop which is called as D flip-flop. So generally D flip-flop is obtained from SR flip-flop by complementing S and R inputs. Okay, so just remember this functionality, then you will understand easily about D flip-flop. So D flip-flop is again obtained from SR flip-flop by complementing S and R inputs. That's all. Okay, so if you take a SR flip-flop with a clock pulse, negative edge triggered, and the outputs are Q and Q bar. So by complementing S and R inputs, so this is D. So as I have told you, single input NAND gate will act as NOT gate. So it acts as inverter. So when you pass it through inverter, then S and R inputs are complemented to each other. Okay, so this is how a D flip-flop is formed from SR flip-flop. So this is the easiest possible way to understand the operation of D flip-flop. So if you want to write the truth table, so as I've told you, truth table is written in form of D and Qn plus 1. Okay, so because inputs and Qn plus 1 will write. Right, so we'll see here. So when D is equal to 0, what will happen? When D is equal to 0, the same input is given here. That means S is equal to D. So S is equal to D. So generally the functionality here is S is equal to D and R is equal to D bar. So S is equal to 0 and R is equal to 1. So what is S is equal to 0 and R is equal to 1 condition? This is reset condition. When reset condition is there, then Qn plus 1 is also equal to 0. So when D is equal to 0, then Qn plus 1 is equal to 0. So when D is equal to 0, Qn plus 1 is equal to 0. Similarly, when D is equal to 1, so when D is equal to 1, what is the value of S? S is also equal to 1 and R is equal to 0. So S is equal to 1 and R is equal to 0. So what is this condition? Set condition. So in set condition, Qn plus 1 is equal to 1. So when D is equal to 1, Qn plus 1 is also equal to 1. That's all. This is the truth table of D flip-flop. Okay, so everything depends on D. So if you want to write the excitation table, excitation table. This is also very simple for D flip-flop. So Qn plus 1 and D, because D flip-flop will have only one input, 0 0 0 1 1 0 1 1. So now because D is equal to Qn plus 1, so D is equal to Qn plus 1 here. So if D is equal to 0, then Qn plus 1 is also equal to 0. So for what values you will get 0 1 0 1 only. So D is equal to Qn plus 1. And since D is equal to Qn plus 1, the characteristic equation is also same. Qn plus 1 is equal to D is the characteristic equation of D flip-flop. Characteristic equation of D flip-flop. So this is the excitation table, this is the truth table, and this is the characteristic equation of D flip-flop. Okay, so D flip-flop is very simple. So it is again obtained from SR flip-flop in order to eliminate these two conditions, no change condition and intermittent condition, by complementing S and R inputs. So this is how we have obtained the truth table, excitation table, and characteristic equation. Okay.